Thank you for joining us for our special session on student voices on the IBL experience. I want to start with a quick public service announcement that Harry Lucas asked me to send to you. He wants me to remind you guys to sign up for 5-minute talks. There's a sign-up sheet in the back that has no names on it. So just keep in mind if you have something to share, put your name on it on your way out. Let me tell you how this session is going to work. We're going to spend 20 minutes with our first presentation, 20 minutes with our second presentation, and the last 20 minutes will be a Q&A panel session with all of the students from both schools. I have some questions prepared, but if you guys have burning questions, I want to give your questions priority. All right? So I'm going to begin by introducing Danielle Champney and her students. They're here. Alex Chong and Colin Schaefer. And they're going to speak about stories of empowerment, the IBL experience for non-math majors in upper division math courses.
Great. Thank you. Ooh. All right. So the first two students here on the panel are Alex and Colin. They're from Cal Poly with me, and they're just going to be sharing some of their experiences in a Euclidean geometry class, which we'll tell you a little bit about. And so in order to share those experiences, I want to use the lens of productive disciplinary engagement, which was put forward in a 2002 paper by Engel and Conant, as a way of sort of evaluating, or my way of evaluating my IBL class success, and sort of give me some benchmarks or some measures for thinking about how my IBL class is succeeding. And their stories will also follow from the guiding principles of productive disciplinary engagement as well. So just to tell you a little bit about this framework, trying to apply the lens of productive disciplinary engagement to IBL seems like a really natural fit. But we should be really careful what we mean by productive and disciplinary and engagement. In other words, one of these things is not enough. In order to have productive disciplinary engagement, we kind of need the combination of all of these things put together, and how all of these things will sort of speak to the success of an IBL classroom. We can see all of them in the typical structures of an IBL classroom, but let's sort of start small. And as we go through the presentation, there will be many things in quotes, sort of like this little quote bubble. And those are direct quotes from the students in my course. I won't read them all out loud to you, but you can sort of take a gander at those. And so the first level is, well, engagement. To have productive disciplinary engagement, we need engagement. Engagement in terms of how are students participating, what proportion of them are participating, how are they responding and engaging with their classmates. And so an example from my students, our class seems full of people who want to share their ideas. This motivates me to bring more to the table every day. But engagement itself is not enough, because we can be engaged in a variety of things and have that not move us forward at all. So disciplinary engagement takes it a little bit further and says, now there's some contact between what the students are doing and the issues and practices of the discipline and the discipline's discourse. So taking it a step further, being in the audience, seeing different ways people thought about and reached their solutions has been interesting, because it makes me think harder about the assignments and the concepts themselves. We're adding the disciplinary piece to that. Still not enough, because you can be very engaged within your discipline and be kind of going nowhere relative to the lesson's goal. So for that, we need to make sure that we have productive disciplinary engagement. And productive meaning, do the students get somewhere? We can see that in a lot of measurable ways, however we define making gains in that particular learning activity. I just threw a couple of quotes up here to show how this could turn to productive disciplinary engagement, like the one on the right. The hardest thing this week was trying to figure out how to do problem 55. I knew how to construct it. I was explaining it. I would have required outside knowledge, and that was not fair game. So you can see that they're engaging in a productive struggle within their discipline, and they're actively engaged. So productive disciplinary engagement is my sort of framework for IBL activities. And the sort of core guiding principles for productive disciplinary engagement, as they were described in the Engel and Conant 2002, and then further in Engel's 2011 and Ksenia Meyer's 2014 paper, are the following: problematizing, authority, accountability, and resources. So very quickly, we'll say what these things are, but then the stories that Colin and Alex will share with you are along these four veins within an IBL classroom. Problematizing, referring to making something a problem, treating it sort of critically like you would any problem, sort of challenging the accepted facts and turning them into examinable claims rather than taking them at face value. Authority in a couple of different ways. The students having authority and active roles in identifying and sort of resolving the problems of the day, whether it's the students that are presenting problems or working with problems, taking on some of the authority, or the authority of the other students to challenge those claims and move the problems forward. The important thing is that we're positioning students as contributors who actually shape the discourse in meaningful ways. Also accountability, so holding students accountability to a variety of things, themselves, their peers, the norms, the content, me, the instructor, and so on. And finally, resources, which I've broken down as sort of fundamental, like having enough time to engage with problems, but also situational, like publicly available norms for the presentations in the classroom, or access to model solutions so we have a goal. So these four sort of guiding principles will take us really far in describing the success of our IBL classroom. And I'll just give you a little picture here. This is a subset of our Euclidean geometry class. This was actually taken more recently, so there's some students missing. But this Euclidean geometry class that we're going to describe was, I would call them a very successful class in which we used, well, as students, I don't want to say that our class didn't have some challenges as a whole in terms of enacting IBL, because it was a learning process for us. But as students, they met all of those challenges and they really succeeded. And we found evidence of that along those four guiding principles I just mentioned. And so we want to sort of share how those were enacted in our classroom with a particular slant toward the empowerment of students such as Alex and Colin, who are non-math majors taking this senior level mathematics class. I think that's a perspective that we don't hear about a lot. We hear a lot about sort of a variety of students in a calculus class, for example, engaging in IBL, or a variety of math majors engaging in this very technical upper division math course. But a particular way that we could be empowered is as a non-math major positioned in this senior level math course, where you have very valuable contributions. And I mean, these guys did an amazing job in that class, but a very different experience toward getting there. So just a little bit about our class. It was in the winter, 22 students. The class was a requirement for several of those students, an elective for several other students, and counted toward an authorization in math for some future teachers. But just to take a look at the proportion here, that many were math majors, and we had several at the bottom there who were not. Colin from liberal studies and Alex from chemistry. It was a Euclidean geometry class, like I mentioned, using an IBL-oriented text with a very typical, and we're not trying to make claims about being very innovative in terms of our structure of our class here. We had a work day. We had several supplementary activities the following day, including concept mapping sort of toward preliminary proving. We had some proofs without words, identifying errors in proofs. And then the final 2 days of the week were presentations and feedback, much in the style of traditional IBL type activities. We covered a typical syllabus and some topics in neutral geometry as well. This course was followed by a complete quarter in non-Euclidean geometry, so we didn't have to cover too much ground. And the requirements of the students were required and assigned problems, completed in Geometry Sketchpad, assembled into a portfolio, which also included a course paper that kind of tied some philosophical ideas with some mathematical ideas, a quota for presentations, so they were actively engaged in that sense, and also a weekly reflection, which was done via email every week and included some of the difficult and easier things of the week, as well as help for me to focus my feedback for those students. And this reflection is where most of the quotes in this presentation came from. Of particular interest, actually, is the I would also like you to know question, because that got some really interesting reactions every week from the students. These are just to give you some context, some sample solutions. They look very typical, some illustrations with some text. We've got very successful proofs. Here's a sample weekly reflection taken from my email. You can just glance there quickly at the types of things they're mentioning, like, I felt like I really understood dilations. Our definition of dilation does a lot for us in terms of making proofs more straightforward. These types of reflections. But we really want to hear from these guys, because this is really the interesting stuff. I just pulled some action shots of Alex and Colin in the classroom doing an amazing job presenting their solutions, challenging other people's solutions, and moving the classroom forward. And so these are sort of stories of empowerment. These are our four. Lauren and Jillian aren't here. Jillian's studying in Europe. I'm jealous, so she's not here to join us. But these are the non-math majors who were in the course, and we're going to take a look at their stories through the lens of productive disciplinary engagement. So first, very broadly, Colin had some really interesting things to say about the way that the math majors and the non-math majors are kind of positioned in this class. And I could say a little bit of it here, how he's sort of pointing to some of the math majors used to this type of proof presentation and the layout, whereas he was more used to the explanation, the verbal explanation, and we kind of had to meet a happy medium because everyone had the same expectations. And so I don't know if you want to say a little bit about this before we move forward.
Okay, so one of the things that I realized when I started in the course was that a lot of the math majors had a lot more of the discipline-specific vocabulary. So, you know, they know all the words for all the different things, and here I am, and I still don't know them. So I can't give you any examples because I don't know those words. But one of the major things that I was trying to work on, and that I think the class worked on as a whole, was establishing some sort of common discourse. So a lot of the math majors, you know, they had those words, but they couldn't use them necessarily because then I'd be like, I don't understand what you're talking about. And so they'd have to kind of use some more simplified vocabulary to discuss these higher level concepts. And I mean, from my end, here I am, and I'm trying to learn the vocabulary, and I'm trying to be able to use it effectively. And I think it we made a lot of progress in establishing this common discourse because it let everybody, it kind of helped everyone because the math majors could reach a broader audience, and then here I am being able to actually, you know, communicate these higher level ideas at all. So.
Yeah, and I think one of the really important things in there is that it's not the concepts that we're really at odds here. In fact, Colin is very successful in all of the math classes he's been in with me, which is a lot. We were counting earlier, I think, is it 6 or 7?
We're at 6, yeah.
We're at 6. So he's very mathematically capable and has a lot of these ideas and is very successful in communicating them, but within this more formal context, it was a little bit of a challenge to bring everyone into the same page. And that's one of the ways that sort of he could be empowered in this way of sort of building his communication and communicating these mathematical ideas. So, do you want to say something else about it? Yeah.
Another thing about that communicating between non-math majors and math majors, the only prerequisite for this course was the methods of proof class at Cal Poly, and I had just taken it the quarter right before our Euclidean geometry course, and I think some of my proofs were actually really long. Yeah. So I think, again, like Colin said, there's the language that the math majors have access to that we don't. But to me, I almost took that like kind of like a challenge to show that I knew what I was talking about. Because I did feel a little bit like I had to prove myself to the rest of the class. Even if I think a good number of the class didn't even know that I wasn't a math major actually, but I still like to make sure I know what I'm talking about.
Yeah, I think that's right. I think that sort of speaks to a broader idea of community as well. A lot of the math majors knew each other from previous classes, and there was some kind of community there. And coming into this community from a different perspective, I mean, it made for an even richer discussion a lot of the time. But the specific things that were sort of part of that discussion, I think were sort of really illuminating for both sides. We can just go through and keep going through a couple of more examples using that productive disciplinary engagement framework, starting with problematizing, and Alex is going to tell us about a specific example here. I've got your slide ready if you want.
Oh, yeah.
Okay.
Okay, so with problematizing, again, I think it's fair to say that at the college level, most students, especially math students, have already taken some form of geometry, probably in their high school. It's kind of hard to dial that back and see what assumptions do we have to use when we actually try to prove these things. So I remember day 1 of our Euclidean geometry class, kind of out of nowhere, we were asked to get in groups and prove the vertical angle theorem.
It may have been before we went over the syllabus. I'm not sure.
It might have been.
Yeah.
Yeah. So on this drawing up here, we have vertical angles, angle A and angle C, also angle B and angle B and D, excuse me. And the way most of us went about it, I think everybody went about it the same way, pretty much, is that angle B and angle A are supplementary, angle B and angle C are supplementary. Supplementary angles both have to add up to 180 degrees, and therefore, doing some algebra, you see that angle A and angle C have the same measure and must be congruent. Again, what assumptions does that require is that it requires we know about supplementary angles, what they are exactly. We have some premise about measuring angles in the first place, what are congruent angles and what are vertical angles. So we left this theorem alone for a couple more weeks, and we eventually, through the textbook, that took us back to this problem exactly. And at this point, we didn't have the notion of measuring angles. We had no idea what degrees are, right? All we had are our basic building blocks of axioms and definitions. But so about the problematizing, we use those basic definitions and axioms to build up to the theorem that would eventually make this proof like one sentence. And that theorem was that congruent angles have congruent supplements. And even some of the math majors had trouble, like they understood that part, but once we get to this, essentially this corollary of that theorem, that an angle is congruent to itself. So angle B is congruent to angle B, which seems trivial, but some of us still had trouble grasping it. And since A and C are both supplementary to B, then A and C must be congruent.
Yeah, so that's a really good example of problematizing, taking this knowledge that they had from high school and they thought they had this proof down, and they did have this proof down, except when we challenged it to go back to the basic principles. And so you're sort of highlighting some of the problems that came up through that and sort of navigating that prior knowledge. We can move on to authority, and these guys had different things to say about authority. Colin had more to say about authority on the part of the presenter, where Alex had more sort of thoughts about the authority on the part of the audience. So maybe we'll hear from their ideas here real quick.
Okay, so when I was got this prompt, about the talking about authority kind of thing, and we're trying to talk about how we're feeling empowered and all that stuff, I kind of referred back to some other classes. So I had taken like a stats class and stuff, and it's very typical lecture based. I go in, sit down, get talked to for 2 hours, maybe fall asleep occasionally. But anyways, but in an IBL class, the one we were taking, we had to figure out the solutions, and we had to be able to understand our own processes, because we were up at the front and we were the ones explaining, and if somebody had a question, we had to answer it. So it was less of a, here's this formula, and plug in numbers and tell us your answer, and it was a lot more of, okay, how can we get from A to B, and how can we explain this to everybody else? Because we had to make sure everybody understood it, not just ourselves. And we had to justify our own explanations and all that stuff. We had to be able to, rephrase it. We had to be able to answer questions, and we had to figure out how to make meaning in multiple ways. And I think having the authority of being up at the front of the class and actually having to do all that kind of let us all have a deeper understanding of the concepts.
Maybe you want to say something about the authority in the audience?
Yeah. So the cool thing about having other students present the problem instead of just our instructor showing us how to do the problem or the solution was that you really didn't feel intimidated like you might in a lecture style. Because I feel even a lot of lecture style classes, the instructor does pretty much on the first day says, feel free to ask questions. But then students are still afraid to ask questions because they always think, this is a dumb question, yada, yada. The instructor, again, says there are no dumb questions, but people still feel intimidated. I feel like that's not a problem anymore because once you see a student on the other side of the desk, if there's, and sorry, the presenter is again not the end all of all truths on this theorem that we're working out, trying to prove, or this problem. They're really just the facilitator or the starter for the discussion, and it's actually encouraged that us in the audience, essentially pay attention, which is always good, but also can contribute meaningful feedback, I guess would be the appropriate word. But so some examples are if maybe the presenter misapplies some theorem or makes unjustified assumptions that they know are true, but maybe we haven't gotten there in our text yet or something like that. Then it's helpful for the audience to hop in, help the discussion. And really this discussion is super helpful because it often gets us more than what we were just looking for in the first place. And an example of this was if we have an isosceles triangle, then we know that both our theorem is, if we have an isosceles triangle, then the base angles are congruent. We have a discussion, yada, yada, yada. We usually get the theorem, no problem, but further discussion through the audience and alongside the presenter gets us to this conjecture. Well, what if we didn't know it was an isosceles triangle? What if we just had congruent base angles? Does that make it an isosceles triangle? And it turns out that was actually a theorem that we were out to prove later. So it just goes to show how having another student presenting and leading the discussion promotes just further and further discussion.
We're going to hear on one more area here, which is accountability from Colin before we transition to the next presentation. But Colin's going to say a little bit about accountability and the various levels of accountability within this classroom.
Yeah, so one of the things IBL does is it makes you accountable for your own learning. Because, Danielle here was the facilitator, and if she set the precedent pretty early that if no one presents it, then we're just not going to cover it. So, I mean, that was only mildly terrifying, but we...
Sounds like me, right?
Yeah. So, I think there were 2 proofs throughout the whole quarter that we didn't end up covering, but most of them we hit. And, that did is it made learning like a student responsibility. It wasn't, learn it for the test. I guess it kind of was learn it for the test, but, it was take it into your own hands and make sure you get the material enough to explain it, enough to be able to apply it. And there was kind of a couple mentalities. It was kind of holding us accountable to ourselves. So like if I don't learn this now, I might never learn it. Like what if nobody goes up and presents it? What if it, what if it does fall on me? And there were a couple, we were all required to have like 3 presentations throughout the quarter or something. So, what if I don't get my presentations in? And then if the other thing was it held us accountable to the class, because hey, if I'm not the one that learns this, what if nobody else does? What if everybody kind of is relying on? It's not necessarily they're all pinpointing me or anything, but what if I could be the one to help everybody out? So you're being held accountable to yourself, you're being held accountable to the class, and in addition to the standard, being held accountable to the teacher and all of that sort of stuff.
Yeah. The last sort of core principle for productive disciplinary engagement being resources. There's a lot of ways you could take resources, but I really like to think about students as resources for one another. And this is true no matter what the makeup of the student population in the class. But the sort of complement of non-math majors and math majors in this course proved to be a really valuable resource for one another, both in terms of sort of pushing for a simpler explanation or pushing for a more specific language, pushing for more sort of detail so they could move forward, and also pushing from the other side to sort of say, step up your game. This is a hard proof, and we're all going to get through it together. So that sort of took us through the 4 guiding principles for productive disciplinary engagement. I think they provide a really nice lens into IBL, specifically a way to measure gains. Like you say, my IBL classroom is really successful. Well, like, okay, successful according to what? Well, these 4 things, you could sort of design measures in these arenas to measure these 4 things and sort of say that these are contributing factors to the success of the IBL classroom. And they're really sort of following in the same vein very clearly, I think, toward the goals of IBL as identified in the literature as well. There will be some discussion to follow, like Victor said, but just to say this was Colin and Alex's first experience with IBL, so feel free to ask them anything. Ask them really hard questions if you want to, because now I get to take a break. But just a little bit about their futures. Colin's going to be a wonderful elementary school teacher. After this next year, he'll enter the credential program. And he's currently working with kids in a kids camp at YMCA, where he's been for a long time. And Alex is a chem major. He's thinking about teaching high school, so let's try to push him toward math. But he's also a calculus workshop leader. It's like a supplemental instructor at Cal Poly, and does a wonderful job as well. I'll transition the slides over for our other wonderful group of students, but thanks for entertaining our stories of empowerment.